Hello, we'll be looking at LCG write-up and crypto category in Google Safe Privacy. Challenge implements a basic LCG to generate primes that are then used in modulus that encrypts the file. The program generates 8 primes that are 512 bits long. The results are used to calculate the modulus and Gaussian. This information is then used to create the private key that will then encrypt the flag and write it to the file. There are two approaches to this challenge. The easiest approach is to factor out the modulus. Players can extract it via the .pem file and then pass it through to a program like UFU factorization. The total factoring time, however, is yet to be determined. I personally spent over an hour waiting for the prime to factor without much luck. The intended approach is to have players figure out the missing values needed for the LCG to then generate the prime themselves and find the factors that way. When looking at the code, we see that the values of the multiplier, the increment, and the modulus are missing. We will need to implement the some mathematical approach to get through this. There are plenty of resources that when searching for LCG CTF that may help out with this. We can use the first 10 consecutive values provided to us for the challenge to figure out the missing values. We can manipulate the LCG equation S1 is equal to S0 into m plus c mod n to solve the unknown. Starting from the last step, we can solve for the increment by modifying the original equation to the form c is equal to S1 minus S naught star m mod n. This requires the multiplier and the modulus to be known, so we can now create an equation to first figure out the multiplier. Considering we have 10 consecutive values, we can use this to better aid the equation of the multiplier. The equation for the first two sequential values will be of the form S1 is equal to S naught m plus c mod n and S2 is equal to S1 m plus c mod n. We can manipulate these equations to then solve for the unknown values. Considering we have two unknowns, we have to solve the two equations. As such, we can derive S2 minus S1 is equal to S1 m minus S naught m mod n and S2 minus S1 is equal to m into S1 minus S naught mod n. Then put in terms of m as m is equal to S2 minus S1 by S1 minus S naught mod n. Considering we are using modular division, we need to implement the modular inverse of S1 minus S naught and the modulus through power of states of 1 minus states of 0 raised to minus 1 modulus. Straightforward. Finally, we will need to solve the modulus. The modulus of an original equation S1 is equal to S naught m plus c mod n can be represented as S1 minus S naught star m plus c is equal to k1 star m. Obviously, we will need to obtain the GCD for the values provided to be able to recover n, since there is a large probability that their GCD will be equal to n. Additionally, it should be noted that x naught x is equal to 0 mod n is equal to k star n. This essentially justifies that we would need to obtain the GCD from a sequence of values generated by the equation in order to find the modulus. We will need to create an equation for sequence that uses the LCG to generate 0, so we can find n. Series T naught is equal to S1 minus S naught, T1 is equal to S2 minus S1 is equal to S1 star m plus c minus S naught star m plus c is equal to m s1 minus s naught is equal to n star t naught mod n. Uh, Reading it can be rewritten as this following equation to generate values congruent to 0, that then find the modulus. This is final piece to the LCG puzzle, as the results from this can be used to find the multiplier and eventually land on the increment. Now that we have the necessary values of the LCG, we can plug them in the equation from the given generate.py script to obtain the primes used for the modulus. The E can be extracted from the .pem file, and the values for from this can be used to calculate the private key and then decrypt the flag better.